to this event, this 7N event today. Just a little bit about the setting for today. The setting is that we have a selected group of you people, so very welcome to all of you with us today. But we also have quite a number of friends on the internet at this very moment. So it's a live webinar. We are going to record it as well, because I'll explain a bit later that we are actually doing a series of 4 of these webinars in order to explain about some very interesting topics going on at the very moment. With me today we have Christina. I'll introduce in a second, but we've looked very much forward to welcoming you as well, and we are thrilled about your presentation, so that will be fun. My name is Thijs, and I'm a VP at 7N, responsible for our advisory services, management consultancy, whatever you want to call it, on a global scale. So welcome again, and as a beginning, I'll just explain a little bit about 7N and what we do, who we are, use a couple of minutes on that, so it's setting the scene, and then to the interesting topic for today, namely Christina. So our DNA is really to focus on our clients' digitalization, travel, and helping out the way we can. And there's a couple of very interesting drivers in the global market space at the moment that is extremely important for us to navigate within. And it's also something that we discuss with many clients that will either be a problem today or become a problem tomorrow. And just to set the scene, I mean, we have been quite thorough in our investigations on research on global span when committing to being prepared to help our clients in their transformation journey. And the 2 drivers that we are mainly focusing on at the moment is this one, which is a survey done by Boston Consulting Group, that has asked numerous of their clients if they have to undergo a transformation. And 80% of those companies have claimed that they need to undergo a digital transformation just in order to survive. And only 28% of those are actually in control of that transformation. So it sets a demand to us to be prepared to help clients in their transformation. And that is one driver that we are focusing heavily on at the moment to be prepared for. We work every day on assisting clients in this journey, and legacy, exit, new people on board, you know all the buzzwords. I don't have to tell you, but it's a difficult challenge. The second driver is that the market space will be lacking qualified people in the future. So again, thorough research has shown that in all domains there will probably be a lack of resources in the amount of 85 million on global span going forward. And we have not mentioned it here, but we've done some extraction of that number, and it's not only us saying it's also EU saying that there will be a lack of people in the neighborhood of 20 million skilled IT people in 10 years on global span. So if we have a driver where there's a huge demand for transformation on the one hand, but not enough people to solve the problem, then we need to work smarter. So we are discussing that heavily every day to see how we can shape this in a way so it makes sense for us and clients. A couple of words of 7N today. What is really interesting here is that we have 1,800 plus consultants working with us every day at clients. And as you can see in the right corner, it's spread over quite a number of both cities and countries around the globe today. Alone in Denmark, we are plus 450 consultants working every day, and that for us, I mean, being smaller back then, it's actually a huge number because it's 100 more consultants today than just a year ago. So we are also undergoing a transformation, being ready for how to govern, how to be in place with processes, internal processes, etc., to capture this demand. We have representation in 9 countries now around the globe, and are proud of this number, which is our success rate with our clients. We only want to work with the best. That's our claim, and working hard to make that happen every day. This picture is actually the basis for 7N advisory. So what we really want to be good at is to capture the center of this triangle you see on the left, on your left hand, namely to be aware of people performance and the processes and methods they work with or under, and the technology they work on. So we have a mantra saying that we want to be value creation experts. Many can claim that, but we really invest in this area and being able to provide value for our clients. If we cannot do that through well-founded business cases or benefit realization plans and so forth, then we are not meant to be together. So it's a mantra for us that we work that way, and that we, with these examples of capabilities, that we focus on doing the right things. Just to touch on one thing that is really a hot topic at the moment, besides what you know with the security and so forth, is really to be able to build business cases, and not the least also the follow-through, meaning the benefit realization plans. So that is an area that we are going to look closely into for the next coming period. So, Christina, just a couple of words on the background for this event as well. We want to give a gift, if you can say it that way, to our consultants and clients by showing you what is it really that combines IT today and space exploration. So at first hand, when we discussed it, it was not obvious how that could be connected. But if we go one back, actually what Christina also will claim in a second, and Anja Andersen also claimed in the last session, is that in order to go out in space, whether it's the moon or Mars or whatever, you need to have the best people, you need to have the best processes, and you need to have the best technology. So that's certainly something that we want to discuss in a way where we can talk about this together and be inspired and understand a bit better from experts like you what on earth are we doing out there, and what is the outlook. So we have had the first webinar in April together with Anja Andersen, one of your colleagues. Today, you. And these are the forthcoming ones. In this episode, I want you to introduce it yourself, but Christina Tolbo, PhD, student at DTU. Very welcome.
Thank you very much. Thank you. Thank you for having me today. I am so happy to be finally out as well as online, not only online. As you mentioned, I'll introduce myself, but I'll also tell you what I plan to take you through today. So, yes, I'll give you an explanation why you should listen to me. You can decide to not to anyways, but I'll give you some key pointers as to why I might know something about this. Then I will tell you what is space exploration actually. A lot of people have an idea that they know what space exploration is, but what kinds of endeavors are we engaged in when it comes to space? And where are we actually going? Like, are we going to Mars? Are we going to the moon? Or will it all be tourism? Could also be. Then in the end, how do we do the things that we do? And is there anything that can be learned from space exploration when it comes to IT or other new frontiers that are really shaping the society as we see it today? So, my name is Christina, and I have a degree, a master degree in physics, and Anja was my supervisor, so I know her quite well as well, if you remember her from last episode. But I kind of derailed quite a lot from what she does. She studies astrophysics, astronomy, which is galaxies, supernova, dark matter, dark energy, and all of that. And I really love that too, but I was also interested in where are we going as humans? Not only where do we come from, but what are we going to do out there if we ever travel there? So I did my thesis in Germany because we don't have a lot of human space exploration in Denmark. You may know we have one astronaut, Andreas Mogensen, but he lives in Houston, so he's kind of out of the country. So yeah, I did my thesis on humans in space and how to keep them alive, mostly at least, or how to make them feel comfortable and not die. That's the conclusion. After my thesis, I was an IT consultant for 3 years. I was in charge of automation of test at the Danish Business Authority, Erhvervsstyrelsen in Danish. And I learned a lot about how to work with IT and how to work in a private organization. Before I got my dream job, I know IT is also cool, but European Space Agency doesn't get much cooler. So I did the jump and I traveled to the Netherlands, where I worked for ESA. It's our version of NASA. So if we have a satellite that's European, it will be a European Space Agency project. And also our astronaut, Andreas, he's a ESA astronaut, not a NASA astronaut. And we have all the same things that NASA has, but we are 22 countries that participate in ESA. And each European citizen pays approximately the price of a cinema ticket each year for astronauts, space station, Mars exploration, and all the utilities that we also use space for, like GPS. GPS particularly is an American satellite system, but then let's call it Galileo, which is the ESA satellite system that you use when you use your phones or other things. And now I'm at DTU Space, and I am quite literally navigating new frontiers because I work with navigation. I work with how satellites find their way. And how do you find your way when you're a satellite? Because you don't have any idea about what is up and down. Actually, there is no up and down. Everything is whatever coordinate system you choose. Also, you only have cameras, but you have to give your brain or the computer brain an idea of how to interpret what it sees, like automatic cars, but just now in 3D and on the lunar South Pole, for example, where the shadows make the craters look very deep and the hills look very steep, or maybe they don't even resemble craters anymore and the computer gets confused. So we make 3D models and try and model a landing scenario, for example. So that's what I do, but that's not what we're entirely here for. You're welcome to ask questions about it afterwards, but I'd like to tell you what space exploration really is. Most of what we hear about is science and exploration, So Mars and astronauts and the moon and all the cool things. But actually most of the money goes to all of these other aspects of space. Especially this one is the one the market is currently at. This is where SpaceX is selling their product, access to space. It's also Blue Origin and the other new private companies that are finally finding a market in space. They all sell access to space. CubeSats, they're very small satellites. They give access to space for students and private industry because they're very small, so they can be launched by mostly everyone. And then we have this one, which is the one that I always mention when people think it's a waste of money, because this is what gives us our climate models, our weather, our way of knowing when to harvest our crops, where to drive, how to have trains and automation here on Earth. And then there's this one as well, which is trying not to get hit by a giant asteroid like the dinosaurs did, try to mitigate the risk, and also try not to get hit by all the things that we send into orbit ourselves. So space exploration is, in the exploration word, only when we go out, but this is a minor part of the total space industry. Right, so as I mentioned, the current market is satellite service and access to space. There's also quite a lot of military applications, national security, as you might call it, surveillance, satellites, and also threats from space, as I mentioned before, like the idea of shooting down an asteroid should it come our way is also a weapon just aimed at astronauts and at asteroids instead of other satellites. But one thing that I can say about the military part is that ESA is purely academic, so there's no defense part of ESA. But all the other space agencies, including NASA and Roscosmos, which is the Russian one, they all have a defense part as well. So Europe is kind of the middleman who can participate in projects with all of the other nations on Earth, because we don't share military secrets with the others. For example, China and US do not talk at all in space. So that's the current market. We make satellites, we make rockets, and we try to not make so much of these, at least in Europe. But there is a change happening. And maybe you saw it yesterday as well in the news, that there was yet another launch of private people to space. The new space tourism aspect of earning money and having a market. Because the people who already supplied the launchers for the scientific world and for the International Space Station, they also, I mean, it's quite evident to go the next step and say, what about offering this up to normal people, or rich normal people, to go to space for 3 days. So this will only grow bigger. This year we saw the launch of Blue Origin and Virgin and SpaceX. So there are 3 competitors, which will also drive down prices to maybe something that a normal Dane or normal person from the Western world at least can earn in a life for some years. So that's very exciting. But what I personally is mostly interested in this is this manned and robotic space exploration. Because we are going back to the moon, and hopefully you can see that I'm not more than 50 years old, so I do not remember the first time that we went to the moon, or the first times that we went to the moon. So for me it will be really new, and it will also be a completely other idea of why we're going there. Last time we went to put a flag, or we Americans went to put a flag and win the Cold War, or at least the space race. And this time we're going to stay, to learn how to live on another planet and to become a civilization that can live on other heavenly bodies. This one comes along with that one, because I will also get back to that. But back in the days, there was no market in going to the moon. It was only prestige. But this time, when we go back to the moon, you can also earn money. And that is why it's accelerating and why we're going. All of the nations and all of the private companies are all focused on the moon, because there is processing and resources to be done. So you can build the infrastructure on the moon that allows access to these resources and to the further exploration of space, to go to Mars eventually. So this is what is currently happening in space. We call this new space. or space 4.0. We like to take it from the other industries as well. And why do we go to space? I mean, I work as a scientist, so I'm just interested in knowing, why is this rock basalt or not? I mean, this is what we do at Mars. Why was there a lake here, or why wasn't there a lake here? But I think the other parts is why most people invest in space, because you get a technological acceleration. You cannot sell it in advance because you do not know what it is. But statistically, we can show that if you invest in space, for example in ESA, you'll get twofold back in earnings from all the industries that will use your product. For example, again with crops and farming. We'll get technological leadership. That's also why countries like United Arab Emirates and Saudi Arabia and Korea and India, China are all now finding out that they should really get invested in space, because if you have the technology leadership, then everyone will buy your technology. Then big data is the new thing, and you get data from space, especially about what happens on Earth. So where are the cars driving, how are the trains going, and where is the natural catastrophe coming from or happening at the moment. So this data and infrastructure gives you the opportunity to help your people here on Earth. And then of course, revenue. So I like to make an analogy because the science have been clear for years that digitalization is a prerequisite in the pursuit of future growth. But in the capitalistic society that we live in, we'll need more resources and new technology developments. So we'll need to go to space to have future growth as well. So I guess we can say that there are two parallel, at least two parallel frontiers that we have to engage in. So I just told you before that the plan is to go to the moon. Maybe some of you know, but a lot of people think the plan is to go to Mars. And it kind of also is, but the moon is in the next 10 years and Mars is after that. This plan, this folder, you might call it, is very short. It's 18 pages long, made by all the space agencies, at least of importance at the moment, in the world. They've come together and said, here is the plan. And the plan is Earth, Moon, Mars. Very simple. There is also a timeline in the top, so you can see what they are thinking. They think LEO, that means low Earth orbit. We already got that under control. We're past 2020, and now at the moment we're building Orion and SLS. At least we is NASA in this case, but the white part of this one is built in Europe, so also a bit of Europe. And the idea is that we'll build a new space station in orbit around the moon to allow access to the lunar surface, and eventually, human lander surface exploration. Having that under control and knowing how do we do it, how do we have a supply chain that supports prolonged missions, how do our bodies handle what's going on when we are there for a long time, then we can start looking at goals of humans on the Martian surface. And why is that? Because I remember the first time I was told that the moon was the new the new target. I got a little bit disappointed because we have been there, and Mars is cooler, but the problem is that Mars is on average 225 million kilometers away from us, and when it's closest is around 54 million kilometers away, and it means that no matter kind of what we do, even if we use a lot of fuel, it will still take us several months to get there, on average around 6 back and forth, right? So we'll have to be in space for a long time, and humans have not been in space for a long time before. Astronauts on the International Space Stations usually stay 6 months, and the longest have been a little more than a year. So we're already past that if we have to go to Mars. Instead, the moon is much easier. It's 3 days away. It's 384,000 kilometers away. If we made an analogy, if I have a football and it's the Earth, and I have a tennis ball, that would be the moon in the same scale, then it would be 7 meters away. Mars, on the other hand, would be a handball 5 kilometers away. That's the scale of how different it is. So if we talk about doing stepwise space exploration, it's really small step, another big step, and then a ginormous step that we can't even fathom, I think, or at least most people. So the plan is to go to the moon in order to prepare to go to Mars. And that's very concrete. We have the Artemis project, which is a NASA project, which will send humans to the moon in the next decade. When Trump was president, it was before 2024, but I think most people didn't believe that would happen. So 10 years, let's say, at least less than 10 years. This is a drawing or a schematic of how it would be. And this is the Orion capsule, which would carry the humans. And this white thing has a really cool name because it's called the European Service Module, and it's built in at ESA, and they cannot fly without it. So every time America says United States for America and all that, then you can say also European Space Module, Service Module, sorry. Artemis is planned to send humans to the moon, but it's not only NASA. I mean, they have the program to land people on the moon, but this is a global effort to build a new space station around the moon, which will be called Lunar Orbital Platform Gateway. And you can see NASA is there, ESA is there, JAXA is the Japanese one, and CSA is Canada, and Roscosmos is Russian. So it's the same partners that have historically worked together in space. At least since the Cold War. And this part of the space station will be launched this year or next year, hopefully, on the SLS rocket that will hopefully finally be finished. So this is the plan to allow access down to the surface again. But as I mentioned, here is also not all of the world's space agencies, but these are the concrete missions to the moon that you'll see in the news coming up. I mean, this one already happened. They both failed. It's not that easy to land on the moon, especially if you haven't done it before. India has actually, that went well with the first one. But Israel was the first private-funded space exploration program. So they were part of Google X Prize, which was Google posting a lot of money into having private people work on going to the moon. They didn't win, no one did actually before the deadline, but they went on with the project and got some funding from Israel as well and launched in 19. Unfortunately, it didn't work. But we'll see to this year, Artemis 1, which is unmanned, but will be a test of the rocket and of Orion. And if it goes well, then we'll see Artemis 2 already maybe in 2022. I think it will be a little bit delayed, but this one will carry the first humans to lunar orbit in more than 50 years. And if that goes well, then the plan is that you'll have Artemis 3, this is Trump's number, right, but a little longer, the first humans on the lunar surface before 2030 at least. And that's pretty cool, because it's not that easy to go there, to land there, and especially to stay there. So if you do go to the moon, everything will try to kill you. You'll have a hard time landing. It will be difficult to land precisely, and this time we want to go to the south pole of the moon, which makes it even more challenging. The other times we always landed around the equator, on the front of the moon, because on the back of the moon you cannot talk to Earth unless you have a satellite. So that did happen. China landed on the back side of the moon, but that was also in 19. So it's very recent that we've been to the far side of the moon. The dust will try to go through your spacesuit, and it will get in your doors and your zippers and everything. So it's a hazard also to your lungs. The atmosphere, there is none, so it's mostly the lack of atmosphere that's the problem here. That also means that we'll have radiation that will increase your chances of getting cancer quite radically, and you can have events where you get so much radiation that it's like almost instant death at least, so that's not good. Micrometeorites are stones falling from the sky. They can puncture your base. Temperature on the moon, it gets very cold at night and not very hot in daylight, but like plus 20 and minus 100. But it will happen quite rapidly. You will have on the moon 14 days of light and 14 days of darkness, which is a problem for your mentality, but especially if you have solar panels and you want energy, then you will have batteries as well. The gravity will be a fun experience. You can jump around and everything, but when you come back to Earth, your bones and your muscles will be weaker, so you will have an issue with being in space for a long time because it will be hard to get back. And then communication, as I said, if you're on the backside, you cannot talk to Earth, and if you're on Mars, there might be 20 minutes delay, so you will never be able to talk instantaneously with your family, and even worse, if you call a mayday, you'll get an answer in 40 minutes. It might be a little bit too late. So that brings to safety and risk. Everything can go wrong, including all of the above, and you cannot get help on Mars. On the Moon, you can at least go home in 3 days, so a little less scary. And then psychologically hard. Being trapped in a can of sardines or a very little metallic compartment with 3 other people that you will have to hang out with for 1.5 years without being able to shower or use the toilet. You can probably imagine that's team building, as we call it. So they actually have experiments with this. What is the best kind of crew to put together? How do you make people work together under stress? And they find that a lot of funny things happen, like especially with hiding food from each other, like trying to be in control of something. And the one thing you can control is you do not get the wine gums today or the candy. I'll have it in my pocket. That happens quite often, so psychologically also interesting. So to go to the Moon, you need, or to Mars for that matter, you need some living conditions that you do not go crazy from, or like completely have a meltdown and just sit there. You need some construction that will keep you safe and also happy. And then you need some supplies, either by being self-sufficient or having a supply chain. And these are the things that we're going to practice, because we do not have this yet. We need energy. We have solar panels, but what happens when it's dark? We also have radioactive cores, but they can explode. They're quite dangerous. Transport is expensive. The rockets are giant. Food is bad and also heavy, so it will be very costly to send. The materials that we use have to be of very specific materials to not be endangered by the space environment. We need to get rid of the garbage. We need to create an atmosphere that has something we can breathe, but also remove toxic parts of the for example, CO2. Then we need security from fires, from punctures, from injuries like a heart attack or something else that can happen. And we need a lot of water, both for hygiene and for drinking. And this is difficult because we have an issue, and that is that the rockets only go up to a certain size. And that's a giant size, but it's not good enough. So when we went to the Moon, as humanity did in 1969 till 1972, we used this rocket. It's called Saturn V, and I also have one here. I'll just bring it in. This one. It's a giant rocket. It's the biggest rocket that's ever been launched to space, and 13 of these were launched back in the days. They are without any failures, so it has a good track record by now. But the problem with this rocket is that the only thing that returns to Earth unimpacted by anything, it's, well, I always drop that, so don't worry about that. I collect it all the time. This one. This part is the only thing where the humans are in when you land in the ocean afterwards. All of that is fuel and infrastructure, you might call it, or things that you need to survive. Just to very rapidly go through how you go to the Moon, you launch this rocket on a platform and hope it doesn't explode, because then it's, I think, a 20th of an atomic bomb, so it's not good. It's also, by the way, 3 times the height of the Round Tower in Copenhagen. And then you spend 2.5 minutes to burn all of the fuel that is in this part. And then you drop it in the ocean. And it also does that in the ocean. And then you fire the rest of your engines here for 9 minutes approximately, and then you also don't need this part, then that is dropped in the atmosphere, burns up in the atmosphere, is never used again. And then you use this little engine to go to the Moon. This was just to get away from Earth. So now you're ready to go to the Moon. On the way to the Moon, you detach this part, and this opens. So in here is the Lunar Module that is going down on the Moon. So you drop the white shells. Here you go. And now you have this. And then you return. Humans are over here. Return. Rendezvous and docking, as it's called, also navigating. Then you take the lunar lander. You don't need this part anymore. And then you go to the moon and you land. You decouple this. Humans have gone over here, 2 of them, and 1 is here. And then the 2 people go down on the Earth. The 3rd one stays in orbit. They are there for a day, not very long, 2 days maybe. Collect some rocks, put up some experiments, and then they don't need the legs either, so they just go up with this one. This stays on the moon. They find each other in space again. Humans go back here, all of them. Now you don't need that part. Then you use the last rocket to go back to Earth. Then you don't need this part. This is the service module, not the European, but the same part. And then you have this left, and you turn it around. You have a heat shield. You come into the atmosphere, burn quite a lot, but the heat shield makes you not die. And then you have the parachute coming out, and you land in the ocean. And this is collected by a helicopter. That's how you did it, and that's to some extent still how you do it, because there is no easy way to do it. That's when you have to go to the moon. These rockets over here are for when you have to go to the space station, which is 400 kilometers above Earth's surface. And these ones are the ones that you know from SpaceX, and this one probably you've seen before too, because that's the ones that exploded. Usually you see those, the Columbia and Challenger disasters, where the astronauts didn't make it. This one was the one. It's called the space shuttle. It's the one that you use to build the space station that we have today. Yeah. So this is the same as I just showed in real life, the separation. And you can see the tanks of liquid nitrogen, liquid oxygen and hydrogen inside these shells. And then the lunar module is in here, and the people are there. And this is their catapult seat. It's called an escape tower. It's to save them if the whole thing explodes. It will take the capsule away from the exploding rocket to kind of maybe survive. As I mentioned, they had the other rocket, the smaller one with the plane on the side, the shuttle. That was the one that they built the space station with. And they did it like this, 1 module at a time, because space is very modular. You can see the year down here, 1998, the first module. And each of these assemblies require a launch of a rocket, but not as big as this one, but still very expensive. And dangerous, because you have to have rockets on each of them. I'll just continue talking. So one thing you can see is that it's assembled also with use of a robotic arm, very ingenious. It's called Canadarm because it's built in Canada. So they like to call things something that has to do with their countries. And of course, the American modules are called Tranquility and Harmony and Destiny. So yeah. And the European module is called Columbus, so we are not better ourselves. It will be launched in a year from now. You will see the European module come up in a second. Harmony, the American one. And come on, Columbus. And also all of the moving around is done by astronauts. Like they have to maneuver everything. There's Columbus. So when we have astronauts on the space station from Europe, they live there, as well as Andreas Mogens. He also lived in this compartment. Both did the experiments and slept there as well. Yeah, it continues for a while, but it ends up looking like that. That's how it looks today. And each of these solar panels, two of them is the size of a basketball court. So quite a giant structure. It's the most expensive thing humans have ever built. It costs more than $150 billion. And I was like, that is a lot. How do I sell it? But I can tell you that the Olympic Games in Sochi, which were the most expensive Olympic Games ever, they cost $52 billion US. So you can have 3 Olympic Games or a space station for 25 years. And I think that's a pretty good selling point. I'd rather have space stations than, but yeah. The only place that people live is down here, and then they have experimental facilities outside, but the rest is structure to survive. You need power, and you need a lot of power, because you have a lot of instruments that require power, and these are radiators to have thermal control and keep the same temperature inside. Then of course you need water. Water is the most important thing. And how it's done today is that we send the water with rockets again. Not as big as this, but still very expensive. Quite often, maybe every 2 to 3 months, a new resupply vehicle is launched to the space station, also carrying food and everything. One of the things that they do very well is they recycle water. So you can reuse 96% of the water on the space station, including, of course, urine and sweat, and when you exercise, there's a lot of that. So the whole system will collect that, and when you have to go to the toilet, it looks like this. This is the toilet on space station. That's for urine, and that's for the other thing, to separate it so that you can clean the urine and drink it again. So they're very good at keeping the water in a closed loop. So we kind of can say maybe check to that. We don't have to send that much water. But we have a problem when it comes to food. I also have some food here. Food is also essential, and especially for our well-being. And we need some nourishing things that we at least can taste. And the problem is they are very heavy, so we remove the water from the food. So if you go camping, it's kind of the same, or instant coffee, it's the same. And then you also have cans, because the Russians had cans, and there's a collaboration between the Americans and Russians and Europeans. So now they just have both, because it's a compromise. Although cans are not as smart, because the cans also weigh a lot in itself. So this is actual space food. You can from Andreas Mogensen's mission, and it looks like this. And it's corned beef with sweet sour sauce and cabbage. And this one is vaniljeran, which I also don't know how to translate, and they also did not. It's even in Russian it says vaniljeran, because they don't know. With the rhubarb, so dessert. And as mentioned, it's in Russian and English. Everything on the space station is in both languages, and they learn Russian if you are an astronaut. And also it's called a cosmonaut if you are a Russian astronaut, and a taikonaut if you are a Chinese astronaut. So it's only us who are astronauts. We could also work on having our plants in plant chambers like this one. It turns out plants like purple light, blue and red, not so much white. So we just put blue lights and red lights on it, and they can. This is a photo from the space station, so they can grow salad in space. Problem with that is salad and other plants, they take a lot of space, and they take a long time to grow, and they need a lot of CO2, and they need a lot of light, and they need a lot of water, and we don't have any of that, not a lot. So maybe we can downsize it. So these are algae, which are also plants, but smaller, and require less water, and are harder to kill. If you know from your local lake, they are just there, no matter what you do. So that's a benefit to us in this case. You can eat those, and that is indeed the plan, but usually I bring so that people can taste, but it tastes like a hamster cage smells. So you're probably happy that I didn't bring it, because they got out of, they are too old now because of Corona, so I can't serve them to you. Then the materials part is you can build a base. This is also an illustration of how it could be done. Build the base on the moon or Mars using the local dust. It's called regolith, to 3D print a wall around an inflatable shell. And the idea with that is that you protect yourself from the radiation. That is one of the biggest problems, because we cannot do anything about the radiation except dig ourselves down, cover ourselves with lead, very heavy, not a good idea. Cover ourselves with water, but we would like the water to drink instead. So this is the going as it is right now, to build something like that, ideally with a 3D printed shell. On Earth we have the Earth's magnetosphere that we cannot see, but looks like this if we could. That protects us from all of this radiation. But on the moon and Mars we are not protected at all. So we'll just get the full blast of radiation. So I talked about where we're going and why, a little bit at least the why, but what is the change that's going on right now? So traditionally, space is very slow. It takes 8 years for a major instrument, like a scientific instrument, to go from commission to launch. And I think this is a little low. Like I at least seen many where I started my studies and they were like, yeah, it'll be launched next year, and it's still not launched. So sometimes it just doesn't happen. And we cannot use commercial off-the-shelf things. So we actually have a problem right now that our navigation cameras and everything are getting old because the chips that are inside are so small, because they're made for iPhones, that they are not good for space anymore, because if they get a particle, a radioactive particle or high energy particle, they'll be destroyed. Because no one cares about the quality of a chip in an iPhone, because you can just buy another one in 2 years, but in space it has to last for 15 years. So we cannot use, we have to make everything ourselves, which makes it very expensive. They'll also not survive the launch itself. It's very noisy and full of vibrations. So we really need to make one-of-a-kind things, and that's how it usually is done. Each satellite is specific made, and everything from the smallest thing to the biggest thing is very planned. And we also have a lot of peer reviews, and everyone has to agree, because it's financed by taxpayers, usually NASA and ESA. For example, financed by the taxpayer. So if it explodes, we always have to talk about how we couldn't have done anything better, or all of this. Whereas SpaceX, for example, they can just explode rocket after rocket after rocket, because the only one they have to answer to is the next one will not explode. And if they're right, then they will still have a money or marketplace. So in traditional space, we have something called technology readiness levels, which there are 9 of them. And when they're technology ready level 9, that means they've been flown before. Usually on a space mission, we'd never go below 7. So it's not so much of a risk place. Actually, it's much less risky than people think. Space is, of course, pushing the frontiers, but in other ways than not in all aspects, because we cannot. We have to rely on proving technologies, old technologies, that we know for certain, for sure, how they will behave under radiative forces and vibrational force and everything. So usually we'd have a spacecraft that has technology little TRLs all the way up here, and then maybe fly one instrument that will then be flight proven. So we'll test one thing at a time. It's very modular. One thing that we do is, this is a photo of the Concurrent design facility at ESA, and it's to have a battle with this issue where everyone sits in their own department. Everyone knows thermal, and I know life support systems, and I know solar cells, and we do not talk together. So when we design a mission, it will always start where there's an expert from each of at least 20 fields that will sit together and raise questions every time there's something that does not fit together, because there's a lot of subsystems. Yeah. So I am nearly at the end. I know. We have a phase A to E when we do systems engineering, and this preliminary design is what is done in the Concurrent design facility. And then there are all of these phases that we have to go through with reviews, preliminary design reviews, critical design reviews, and there are so many reviews that I didn't list them all here, but they're quite frequent and very thought out. It's always the same process. There's you can quite frankly say there's nothing new. It's always the same way to do it. And then the testing, the Q&R is really thorough. We send the components to other European countries to shake them on a giant shaker down in Holland, actually, the Netherlands. We also put radiation on them. We put them in a giant black chamber where they have simulated the sun with all of its force, both in heat and in radiation, and we put it into vacuum to see what that will do with it, and we shake it and we drop it and we throw it around and kick it until we're really sure that it will not be destroyed on a launch. And this takes years as well. So one of the things that are changing is that this is taking fewer years, because we're getting to the same place as the iPhones, where you can just buy another one next year, because they're not as expensive as they were before. Still expensive, but much less expensive. And that's what, for example, SpaceX is doing. Yeah. So new countries are joining: China, India, not India, China, India, and Saudi Arabia. Russia has been there, America has been there for ages, and they are going to space as well. So in the end here, the key takeaways that I hope were at least between the lines of what I said is that traditional space is slow, we have to have supply chain resilience and develop gradually. We need modularity, very important, and we have to do complex projects with concurrent design, because we've shown that it's really important that we find the mistakes in the beginning. Kind of, that's not a surprise, I would say, but but still. And then we need to test on different levels in simulated environments as well. So, for example, one of the space missions that I'm working on is that we want to fly a formation flight, so 2 satellites that fly in the same position all the time. And we're working on the camera at DTU, only the camera, some other things as well, but especially the camera, let's say. And we test that so thoroughly at DTU, then we send it to NASA, or in this case it's ESA, and ESA will integrate it with the payload sitting next to it, do the same test again, then integrate it to the system, do the same test again, but at different scales, of course. So we test everything so thoroughly that I can say, as an IT consultant in test, it was not the same. But it's kind of like unit testing, and then you know the test part, right? Yes. So cooperation across cultures and languages and ideologies is key as well, because we have to collaborate with the Russians, for example, or India, and they do things way differently than we do here in Europe, especially. And there are also some ideologies, for example, that United States do not want to work with China, but ESA can. So sometimes we kind of work with both, and we're the middleman. It's just on different ends of the satellite, you can say. Like, as long as we do not share the key technology in there. So we really have to make compromises, and I think the space station is a proof that humanity can actually work together, because we cannot maybe agree on Earth, but on the space station, Russia and United States have worked together since the 70s on building space stations, and I think that gives hope, I think, for the future. So I was asked to leave some time for questions as well, so that you can stop me on the things that were maybe not that clear, or if you have any additional questions, ask me about anything. Yeah.
And if you have any questions, we have a microphone here, but otherwise, I think we also had some questions online.
Yeah. And sorry for speaking so fast. I want to say everything, and I can't. So I have to rush in the end.
Okay, this one is quite interesting.
Yeah.
So just you briefly touched upon it. So yesterday we saw yet another billionaire go into space, but is there anything us more mortals can gain from billionaires going to outer space?
I think yes and no. I mean, it depends on if you're pessimistic or not, and I'm maybe a little bit pessimistic, but I'll try to not be. The thing I think we can gain is preserving our space. So we have one big issue at the moment, is that everything that we launched into space is debris in orbit around the Earth, and will eventually create kind of like a wall and wall us in. And I think there is no there's no reason to clean it up, because you do not earn any money from cleaning it up, and there is no responsibility of who sent that thing 70 years ago or 50 years ago. But if you have tourists and it poses a hazard to the tourists in orbit, then maybe someone will clean it up to secure their market. I think that's maybe the positive thing that I can think of. The not so positive thing is they could also just create more debris and be debris, like, oh no, there's a commercial one coming by, we cannot launch for Mars. That will be the sad version of that. But I hope for the first. Yes. There's also a question over there.
Yeah.
Yes, thanks for a very interesting presentation. I was actually surprised to hear about so much collaboration. I definitely did not know that was going on. I mostly read articles about a new Cold War in space, and space or satellite killing satellites and that kind of stuff. So what is your opinion, or do you have any insights in, are we facing a new military space race or something along those lines?
Yeah, I think it won't be a military space race, I hope really, but I think it'll be a commercial space race, and sometimes they go hand in hand a little bit, because there is some resources to be gained, and there's also some questions about who owns what in space. Like back with the military epoch, or what you might call it, there were some laws that were made, like you cannot own the moon and you cannot put mass destruction weapons of mass destruction in space. Did not say anything about normal weapons, unfortunately, but still there's some giant rules, or big rules. But what happens when you build a base on the moon? Do you then have the surface underneath the base, or what about if you move the base around? Like if you have a moving base, can you then, I don't know, drive around in a square and own the whole place? And that's one of the things that is going on right now with the laws and legislations of, is it for the benefit of mankind, or is it for the benefit of SpaceX or the Chinese government or whoever goes there first and does things first? There is a lot of collaborations. I think the biggest problem is the non-collaboration between China and the United States. Russia is in the club, I want to say, but there is a whole new space race with China, where China is just doing all of the same things that I just said, building their own space station, have their own lunar program, have their own astronauts on their own with the funds of the national of the nation. So they're not reliant on private investors or taxpayers. They just say, we go here and do it, and then they do it. So that's a whole third road of going on the way. Yeah, I hope that kind of answered some of it.
Just a last kind of, what should we be looking forward to next in the coming months, days? I know you had the timeline, but yeah. What's the kind of next big thing that's going on?
I think the thing that I look most forward to is the launch of Artemis 1, which will be hopefully this year, probably next year. And it will be very cool, because if it's successful, then we're ready to send, hopefully, humans to the moon for the first time in 50 years. So the last people that looked on the moon and left it and went up a stair was in 1972, and they're almost none of them are alive anymore. So it will really be like the first generation, a new generation that will see the moon close by and also see the Earth on the sky, like the marble that we talk about and everything. So I'm looking forward to that happening again, you might say, but in high definition this time. Yeah.
Nice. Well, we're actually running out of time, but we just want to thank you very much for joining us here today. And I don't know if Thijs has some last...
Yes, I do. So, one thing, Christina, I'm... yes.
Thank you.
One thing that I'm really disappointed about is that I imagined when Anja spoke about outer space, and that we would see it in our lifetime.
Yes. Well, then you just have to bend the laws of physics. So, but find some new laws of physics. So it's possible. It's just I left the domain. Let's say after working on that.
Thank you so much. It's extremely interesting, and why we brought you today is because we want to see if we can, in our daily life, if we can learn something. Yeah. And be better. So in that context, I mean, these are for you.
Well, thank you. I'll be back on the stage.
Yeah.
I was running away.
I'll watch out.
Yes.
And thank you so much for coming today.
Thank you. It was a pleasure. I hope you learned something new.
And so we are done. And for those of you that want to stay for a little snack and a drink, you're welcome. And otherwise, I mean, thank you so much for today. Anything, Rasmus? No, it's okay. Good.
Farewell to the people online.
Yes, absolutely. Thank you. So also farewell to you guys out there, and see you in next time. Thank you.